sir.
I'm not a scientist and I'm not a gemologist, so
I'm not a scientist or a gemologist, so if I should ask the question differently, please correct me. The slide that you had up with the age of the mines, showing the Akati mine as the oldest material.
Can you back that
and
slide?
Are you dating the age of the mines from studying the diamonds, or are you aging the diamonds by what other material you're finding in the mines or in those pipes? How are you actually dating?
Okay, we're taking
Which?
two different things.
Yes.
One is the age when diamond crystallized. Another age is when the diamond was brought to the Earth's surface by the magma, by the volcanoes. The age listed here are the age when diamond crystallized. The kimberlite eruption was much younger to bring this diamond to the Earth's surface. So that's where somebody says the kimberlite eruption is just like a vehicle, like a bus, to transport the older materials in the Earth's internal to the Earth's surface.
In each kimberlite pipe, can you have from different volcanic events from different times, or is every time there wasn't a volcanic event, it's a new pipe, even if it's in the same location?
It's true. So one kimberlite pipe, you could have a multiple phase of eruption. So if you move to, let's say if you go to visit diamond mines, you will find the rocks of kimberlite are different from this area to that area. We can use other radioactive elements to date the eruption of the kimberlite. Normally they are very close to each other in terms of the age. In geology we use million years as the minimum unit. So when we say very close, that it could be a few minutes. And we can date it quite accurately.
Thank you. Sorry, last question, non-sequitur. The slide beforehand, or one of the first with the NV Center, when you had shared that for technology purposes, you're using NV centers rather than silicone. Can you please share the significance of that, or how that is important or plays a role today?
Okay, I'm not qualified to tell you the science, how to use NV center for computation. But the NV center is, I can tell you a little bit of features for NV centers. They are very bright, means it can be, the fluorescence from NV center can be easily excited. That's what for computation you need. You put a signal, it react immediately.
Currently we use silicon.
NV center are stable since the host material is a diamond. It can still function when the diamond is a very high temperature. Because the diamond, as long as the diamond is stable, NV center is going to function. That means the new computation could happen at a very high temperature. That's what semiconductor could not do. And of course, it is faster, and it can be used also in many other areas. I'm not qualified to tell you how to build up new generation of computation, but many scientists in the world, the quantum science, are paying attention to NV centers. That's why there's so many people grow diamonds, try to use for industrial applications. That's one of the potential applications.
Does aside from being easily excited, the fluorescence compared to the phosphorescence staying excited, does that matter? Does how long it continues to stay excited have any relevance in this, or one is mutually exclusive from the other?
Sorry, I will not be able to answer that very well. But what I mean is this center is at 637 nanometers. In terms of the energy of this center is not very high. So anything above 637 nanometers, that basically orange, blue, this light, UV light, will be easily excite the fluorescence of this peak. That's how they use it for computation. Jen.
Yeah, great presentation. We have got a question. I would rather take it to the session before Pritesh session. Every diamond, you talked about defects. So every natural diamond is never perfect. Probably natural diamonds are the only diamonds which are not perfect, and they will have defects, and they could be probably promoted as not perfect diamonds. And those could be extremely, become one of the most important character for natural diamond. Because I come from a manufacturing center where a lab-grown diamond manufacturing, cutting and polishing takes less than $10, and cutting a natural diamond takes $200 minimum. Just because you are working with defects and inclusions, it requires a very different kind of skill sets, and the diamonds are produced not symmetric. These could be used for promoting natural diamonds, could be one of the very important criteria to differentiate between a natural diamond and a synthetic, isn't it?
I think you that's a very important point. I mentioned that 98% of the natural diamond would be black color if the defects are not naturally reorganized in the nature. Because they have hundreds ppm parts per million. It's still very, very small parts per million level of impurities. And synthetic diamond, on the other hand, they are type 2A diamond, type 2B diamond. Their impurity normally is in the 1 ppm, so 1 parts per million level of concentration. So in general, except for this commercially extremely important large grade 2B diamonds, natural diamond, 1A diamond, normally they have a much higher concentration of impurities than this in synthetic. It's not necessarily bad sense in impurities create all of the additional features, otherwise you will not see this dramatic, impressive features of natural diamond. But what Janik mentioned is yes, that's absolutely correct. And natural diamond, but synthetic diamond are standardized, uniform,
Yes.
very small range of color range, clarity range. I think that explains and mentioned why we don't have to use or we shouldn't use the 4C criteria grade synthetic diamonds because they don't have the variations. It's just standardized, and we say natural diamond, every stone is unique. You cannot find two diamonds that show similar features. But when we talk about synthetic diamond, it's getting difficult. Someday we may not be able to separate two synthetic diamonds with the existing technology we have. And I have to emphasize with the existing technology, we might not be able to separate two synthetic diamonds. But for natural diamond, we are always able to separate them. That's why we can track it, and that's why we can offer the origin service in GIA.
You spoke about the growth and super deep diamonds versus 200 to 400 kilometers versus 600 to 800. Because they ultimately come to the surface thanks to kimberlite pipes and volcanic activity, when you consider that a 1 inch, for lack of a better term, movement under the Earth's surface could mean that the diamond could be erupting thousands or hundreds of thousands of miles away in a different area of the surface of the Earth. So when you speak about Argyle or Zimi or Ekati or any of these mines, in reality, its growth or its birth was in an area probably very much next to each other, but its travel and find could be in a different part of the world. So how do you differentiate what is really the age?
Thank you very much for mentioning that. I forgot to tell this point. Diamond formed in the much deeper part of the Earth. If you compare with the ruby sapphires, the deeper the materials, the less the impurities will be. Yeah, this is diamond formed in the deep part of the Earth. They're in the generally a uniform environment. They don't carry geographic information. The diamond formed in the Earth's internal depends on the plate tectonics, how the crust moves. It could erupt to Australia now, and it could erupt to Africa, but they are basically the same because the crust of the Earth has circulated quite a few times over the 4.6 billion years of the Earth history. Of course, the plate tectonics started up a little bit after the Earth's formation. That's the reason why we in GIA concluded we cannot determine the geographical origin of a faceted diamond by only analyze the diamond. We have to track it from the beginning. We cannot do the service like the industry is doing for ruby, for sapphires, for tourmaline, for peridot. They can analyze these minerals and get some idea, at least some ideas where they come from. But for diamond, our conclusion is with the available technology at this moment, we have no chance to determine the geographical origin of a diamond by analyzing it. It was a topic in the last few years. Somebody said, oh, we invented technology, we can do it. I never trusted it. If somebody asks you to invest it, be careful. Yes, please.
The slide where you were showing the tectonic plates, I think it was earlier in the presentation where you were showing the Eurasian plate and the Atlantic plates. This one, oh yeah, just go back.
This one.
There.
Uh-huh.
You see that point between North American plate and Eurasian plate? It cuts in the middle of Iceland. I was actually at that point. And Iceland has so many volcanoes. I mean, but there are no diamonds there.
It's no chance because you should go to school to study geology. So Iceland is here. Yeah, Iceland is here. Right in the middle
Of the ocean.
Atlantic ridge. That's where the new crust is forming.
Yeah.
So in Iceland, you will see a big fault. This side moved to west, other side moved to the east. That's because the new crust is forming. And everything here is very new. They will not see any old continent. And everything here is hot. Diamond will not survive. But instead, they got a lot of hot springs. That's the good
Thank you.
You get a free spot.
Dr. Wang, one more question. In the few years that I was not writing or talking about diamonds, I worked for a boss who was a geologist and was passionate about semi-diamonds. And I see that if you
for
chart
Eddie. Yeah.
diamonds are pretty young.
Ja, maar of
relatively.
afkom.
The cutters in this
I know
company,
him.
our company were cursing the Zimi diamonds because they were so difficult to cut. Is there a relationship between age and composition?
To cut to preserve the color or to cut to avoid breaking?
Yeah,
Which?
the breaking.
Avoid breaking. Okay.
Yes.
We studied the Zimi diamond because Zimi diamond is a beautiful yellow color. They call what's that bird's name? I forgot. Canary color. Canary color is from isolate nitrogen. We have a question is how could isolate nitrogen in this diamond survive the process to aggregate together? Most natural diamonds of nitrogen are aggregated together, that's why the color disappeared. But for Zimi diamond, it has a ppm level isolate nitrogen that didn't aggregate. So for us, for geologists, we immediately have a question, how that survived the geological process?
So how?
So I was
How
very
marriage
lucky actually.
survive?
That's who did this project is the first postdoctor in GIA, and I was very honored to have my own postdoctor. Her name is Karen Smith, an excellent scientist. She picked up this a project to study how this diamond survived. So she dated this diamond. It's about 700 million years old. So it is the youngest diamond we ever found, but geologically it's not that young still. Not 600-700 million years. So have enough time for nitrogen to aggregate. So her explanation is once the diamond formed, there must be some tectonic process to push these rocks in the Serrano area to a lower temperature area. So when the temperature is low, that basically stops the aggregation of the nitrogen. I really don't know how that diamond is harder to cut, and we didn't study its mechanical features of these stones, but very good for me to learn, probably to think about it.
I'm sorry, as the chief whip, there is one more question from the gentleman here. Yeah. Because we need
Thank
to
you.
finish now.
You showed that the isolated nitrogen effect and nitrogen vacancy significantly influence diamond color. I want to know how can you use this to differentiate a natural diamond to a lab grown?
natural diamond and synthetic diamond, they have, in general, very different defect, I would say, configuration. It's not an individual defect, but if you put all the defects together, they have entirely different structure or different configurations. You mentioned the MV centers. Almost all CVD synthetic diamond, they will have a detectable MV centers. MV centers fluorescence orange and red. So mostly you put a CVD diamond and UV light, you see orange or red fluorescence. That's from MV centers, right? But for natural diamond, only very, very small part, they have MV centers that's still detectable. That's called Golconda pink. Golconda pink is from MV centers, but most, I would say 99.9% of natural diamond, their MV centers are so low, they don't impact the color appearance, they even not impact their fluorescence. You don't see orange or red fluorescence from vast majority of natural diamond. You'll see green, mostly it's blue, right? And then see green, and something like that, but you don't see.
Thank you.
One more and that's it, because we really need to wrap this up.
Looking at this display, this slide, are you able to tell where diamonds would likely be found, looking at where the tectonic plates intersect?
Here. That's another continent that has not been explored yet. It's covered by ice. Diamond has to be found in the very old continent, like in here is the old continent in Africa. I mean, where Africa is. Yeah, here is the old continent. The one piece of the old continent we have, human being has not got a chance to explore carefully, is in the Antarctic. That
Wow.
might
Next
have-
frontier.
Okay, so just an extension to my earlier question. How would you explain diamonds being found in the Golconda region of India?
Sorry, I will not be able to answer that question very well. But let me show you, let me find out where India is. India here. India has a very old continent here, so we call it Keraton. India has a Keraton. You have kimberlite here. So, but I think Golconda is somewhere around here. I don't think anybody knows there's a dramatically important, big, large, historically important stones where they come from. No idea. I was talking with some clients of GIA. If someday I can visit Golconda area, so I'm looking forward for that opportunities.
Dr. Wang, we have to wrap this up.
Wow.